Today we are going to deal with the carbon resistors and how to calculate the value of the resistance using the color codes. Okay, so this is the carbon resistor which we are using in our circuits, and here we can see the color codes on the surface of the resistors, and this brown color marked as a particular ring, and another ring is black and another one is red, and this fourth band is called as the tolerance band, which is in gold in color. These tolerance bands may be in red color or brown color or silver or gold. Okay, each color has its own tolerance range. And now if you want to calculate the value of the resistance, there are some rules. So now what is the value of this resistance? This carbon resistor has a particular value of 1 kilo ohm, and the tolerance is plus or minus 5%, which means that the value of this resistance is 1000 ohm, and this 1000 ohm is toggled between plus or minus 5% of the value of 1 kilo ohm. Okay, let's get into detail. And this represents the carbon resistor. Here the resistors of different values are commercially available. To make a resistor, carbon with a binding agent is molded into a cylinder, and wire leads are attached to the cylinder, and the entire resistor is encased in a ceramic or a plastic jacket. The two leads connect the resistor to a circuit. These resistors are widely used in electronic circuits such as those for radios and amplifiers, etc. The value of the resistance is indicated by 4 colored bands marked on the surface of the cylinder. So now these are the color codings which is drawn on the surface, and inside the interior part of the carbon resistor is shown here. Here it has a helical cut to reach the desired value of resistance, and these are the end caps with the leads. This is one of the lead and this is the other lead. The leads will be on both the sides, left and right, and this represents the ceramic substrate, ceramic core, which is made up of a material which is a mixture of ceramic and metal, which is called a cermet. And there is a thin film, metal thin film coating is given for conduction. So this is a thin metal film, and over which a protective layer of coating is given for the particular resistor. Okay, and this is how we can calculate the value of resistance. If you have any resistor and it will be having its own color code, and from the table we can able to calculate the particular value of the resistance, and for that purpose we have to keep in mind the color and its code. So these are the colors and the respective codes. The codes are starting from 0 and ending with 9. So 0 to 9 there are 10 codes, and here these colors can be kept in an order. So to remember the order of these colors, we have to keep in mind a mnemonic which is called as BB Roy, Great Britain, very good wife. Let me tell once again, BB Roy, Great Britain, very good wife. And this is the mnemonics which we have to bear it in mind. So starting with black, first B stands for black, and second B stands for brown, and Roy, R for red, O for orange, Y for yellow. And Great Britain, Great stands for G, green, and Britain stands for blue, and very good wife, very stands for violet, and the good stands for gray, and the wife stands for white. Okay, so you have to bear it in mind this mnemonics in order to this order should not be changed, then only it can be matched with the respective codes. Okay, and here black represents 0, Brown represent 1, red represent 2, and orange represent 3, and yellow represent 4, and green represent 5, blue represent 6, and violet represent 7, and gray represent 8, and white represent 9. And this gold, silver, red, and brown are commonly used as a tolerance band, and the value of this tolerance band is given here. Most commonly used tolerance are brown, red, and gold and silver, and these tolerances are never been used because they are very less. They can be neglected. These tolerance will not come into play while during the calculations. And suppose, for example, here we have given a resistor with respective color codes. The first ring represents brown, so for brown we have to stand for the code 1, and for black the code is again 0. So for the first two bands we have to write the numbers 1 and 0, and we have to go for the third band. The third band is red, and for the third band is called as a multiplier band, and we have to multiply the value of the third band. If the value of the third band for red it is 2, so for 2 we have to multiply with 10 power 2. We have to go for 10 powers. It must be a multiplier, so it must be multiplied with 10 powers of 2, and 10 into 100 gives you 1000 ohm. And the tolerance is represented in the last band. This tolerance band, fourth band, is called as a tolerance band, and that is gold. And for the tolerance it is plus or minus 5%, and the value of this particular resistance will be 1000 ohm plus or minus 5%, or 1 kilo ohm plus or minus 5%. So what is the percentage here? 5% represent for 1000 ohm. The 5% is, what is the value of the 5% for 1000 ohm? So if you want to find for 10 ohm, you divide it by 10. So for 1000 ohm, if you divide it by 10, 100 ohm will be the percentage, 10%. 100 will be the 10% of 1000 ohm. So we have to divide by 2. So 50 ohm will be the 5% for 1000 ohm. So the value will be depending on the tolerance. That is, it can be toggled between 950 ohm to 1050 ohm. So if you want to connect this resistor, in case if you are having a circuit and if the circuit needs 960 ohm, definitely we can choose this particular color code resistors, and this is suitable one because it has a plus or minus 5%. So 960, for instead of 960 ohm it can be utilized. Also, for if you are having a circuit, if the circuit looks for a resistance of 1030 ohm, definitely we can go for this resistance. So 1050 ohm, up to 1050 ohm it can be tolerable, and the tolerance range is from 950 ohm to 1050 ohm. This is the calculation for 5% plus or minus 5%. And if the circuit needs the resistance of 1100 ohm, definitely it is not suitable. So this is how the tolerance band will be helpful in choosing the particular resistor to connect to the circuit. Okay, and this is how we can be able to calculate the resistor value of the resistance using a multimeter. By connecting the two ends to the respective terminals of the multimeter shows a reading which is 972 ohm. So definitely due to tolerance it is reading 972 ohm. Okay. While reading the color code, hold the resistor with your bands to your left. So keep in mind the color bands must be only on your left side, and the metallic band, the fourth band, the tolerance band, should not be on the left side. It never starts with the metallic band on the left. Okay, and this is another type of resistor which we are using, a variable resistor, and it has 3 terminals with the third adjustable terminal. The potential at the third terminal can be adjusted to give any fraction of the potential across the ends of the resistor. A potentiometer is an adjustable resistor which consists of a wiper that slides across the resistive strip to deliver an increase or decrease in resistance. So this is the knob which can be rotated. This is the cap on the knob, and this cap can be rotated so that the knob will be rotating, and due to the rotatory movement of the wiper inside the arrangement, we can able to increase or decrease the value of the resistance. Therefore, the level of the resistance will determine the output current. Okay, and it is also called as pot meters. And now this is how a potmeter is going to be worked, and this represents the voltage, frequency and speed of a potentiometer, speed pots. And here this is the knob which is to be rotated, and this represents the resistive element, and this represents the wiper which is connected. And by rotating the knob, the resistance value can be altered. By altering the value of resistance, one can change the value of current flowing in the circuit. So this can be obviously more clear with this potentiometer arrangement. It represents Ohm's law, and here this is also one of the major advantage of this potmeter. The value of the current can be decreased or increased. Okay, and this type of potmeters are used in power amplifiers, etc. And this graph represents the change in resistance with respect to the rotation of the knob. And these are the various graphs for various types of potmeters. So there are various types of potmeters. This graph represents the knob rotation to the change in resistance value. Okay, so far we have discussed about the carbon resistors and the types of carbon resistors, and how to determine the color codes, how to explain the determine the value of the resistance using the color codes. So don't forget the BB Roy, great button, very good wife. Okay, and thank you. Keep subscribing my channel, so Ranganathan Physics. So learn physics with a very well known basic facts. Thank you.